Hey everybody. So here we are again, another circuit problem. For mid-size circuit, we got four resistors, two independent sources. All right, and they say that we have a current, output current IO, passing through this 2 kilo ohm resistor. All right, they just want us to find that output current. So yes, you could find this using KVL and KCL, but if you think about it, you got 1, 2, 3, 4, 5, 6 loops, 1, 2 nodes. That's 9 equations. Not doing that. All right. So remember, if you can help it, odds are you probably don't want to use KVL and KCL. You probably want to use a simplification method. So after that, you look for, I guess the first thing you should look for is current divider, voltage divider. There are no current divider to voltage dividers here. Okay. So after that, you just try to reduce the circuit. So in terms of reduction, so far we only know resistor reduction and source transforms. Well, right now, none of these resistors seem to be reducible. None of these are in series or parallel with anything. But if you think about source transforms, you will be able to get some reduction happening. So if I look at, I look for the source transform situations. All right, now remember, source transform is a situation where I can have a voltage source in series with a resistor between some two nodes, and it actually equals a current source in parallel with the resistor between the same two nodes. That's a B. Now this is R. The R is going to stay the same, but the source is going to be transformed, where Vs is equal to Is times by R, and Is is equal to Vs divided by R. Okay, so it follows Ohm's law, but that's just a consequence of what's happening. It doesn't mean that a source runs on V equals IR. Never say a source is V equals IR. This just happens because of the nature of the transformation. All right. So with that being said, all I have to do is look for either one of these situations, and I can transform backward and forward as I need to. Well, I see a current source in parallel with a resistor here, and I see a voltage source in series with a resistor here. Sometimes you're going to have two source transforms that you can do, and out of those two, sometimes you only need to do one, sometimes you need to do both. All right, what I'm going to do is I'm actually going to run both transforms and see what happens. Ooh, both transforms. All right, so the first one we're going to have, you know what I'll do? I'll put this in green. It's going to be difficult. I'll just put it in green around it. Trying to go back is just too much. So let me do the first transform in green. I have a voltage in series with a resistor, so I'm going to have a current in parallel with a resistor. All right, the resistor is going to stay the same, so it's going to stay at 6K. They are both between, let's call this A and B. All right, A, B, that means this is like C. Okay, and this is also B. So I still have A and B. All right, it's going to be 6. The current is going to be I is V over R. 6 over 6 is going to be, and it's a K, so it's going to be 1 milliamp. Okay, so that happened, and then what was left is everything else. So the remaining circuit is not affected. I have my 2K. That's going to be difficult. Let's see what I can do. This is 2K, and it has an I passing through it. All right. Then there's a 3K that was on top, and then I have to worry about transforming this one right here. So this was a current in parallel with a voltage, so I'm going to put a current in parallel with a resistor, so I'm going to put a voltage in series with a resistor. Okay, the resistor says it's 3K. Now, the question would be, a lot of students will say, well, do I put the resistor on the right branch? Do I put it on the top, or do I put it on the bottom? It does not matter because it's in series. Remember, if it's in series, I can rearrange them in any way I want because they're all in series and the current and voltages are not affected. All right. So what I do is I just put the resistors next to each other. When I reduce, I try to reduce with when I transform, I try to transform and put the resistors next to each other so I can see any parallel or series combinations that may result. All right. The question is, and I didn't ask it here, I should have. What is the polarity of this voltage source? Is it plus minus like this, or is it minus plus like that? Okay. Well, the answer is it is plus minus. How and why? This current goes up into C. So the current has to feed upward towards C. This right here would be, this right here is going to be my node C. Okay. C and B. So my convention is to have the current pass upward from the, I guess not pass upward, it comes out of the positive terminal of the voltage source. So the current comes out of the positive terminal of the voltage source, it goes towards C, which is in line with what was happening here. So this is going to be my polarity. And the same thing happened there. If the current goes into A from the voltage source like that, I need to have a current pointing up into A. like that, it would go into A from that. Okay, so it makes sense, and you have to do that. You cannot just say, oh, I'm going to put the polarity however I want. It does not work like that. If you plot the polarity, you are wrong. Okay, you're not going to get the right answer, I promise you, unless you just made a double mistake and it just happens to work itself out. But that is consequence, not something that you're doing right. All right, so here's my voltage source. Voltage has got to be current times resistance. 3K times 2 milli is gonna, the K and M are gonna cancel, and I'm gonna get a 6 volts right there. All right, so this is my new circuit, but it's actually not been reduced. It's just been transformed. This circuit between A and B is electrically the same. So this IO is actually going to get the same value with this circuit as it would with this circuit. All right, we call that electrical equivalence, and it's really, really convenient. Now, with everything as it is, I can see some series and parallel stuff happening. All right, these are in parallel, but I'm not going to combine them. Why? Because if I combine these two, I will lose my IO. IO is passing through the 2K. Yes, these are in parallel, but just because something is in parallel does not mean you have to stick it together with something else. Do not stick these together. You will lose your IO. You will not be able to get to your answer. Okay, so these are kind of forbidden. Don't mess with this. If they were in series, I could, but they're not. So what I have left though is this 3 and 3. So 3 and 3 are going to combine into a 6. So I'm going to have this 1 milli right here, this 6 right here, and I know it's K, it doesn't matter. This is my IO, and it's connected to a 2. This is my 6, it's K, plus minus, and that's my 6 volts, okay? So I shrank it just a little bit. From here, I got to do one more shrink. Now, a lot of people think, oh, if I source transform this element right here, this segment right here back, then I will have basically undone my work. Nope, that's not how it works. When I first source transformed, I was source transforming with the 3. All right, now I'm source transforming with the 6. You're going to see when I transform this back into a current source, it's actually going to give me a new set of information. So what I have at the end is my 1 milli, a 6 here, that's kilo. I'm just not noting it. 2 with the current that I care about. And I have the 6 now, because it's in parallel, because this is my reverse transform. This current was, the current will push up out of this, so the current has to go like that. I is V over R. V over R is going to give me a 1. 1 and 6 is not the same as the 2 and 3 that were existing in the beginning. So yeah, I went from here to a voltage source and then back to a current source, but I didn't go back. Technically, I went forward to a current source, all right? So keep these things in mind, all right? Whenever you have a question, you ask yourself, does this work? Will this work? Sometimes that means that you probably shouldn't do the thing that you're thinking of doing, and other times that means you need to think about the consequences, the electrical consequences of what you're doing, and if it makes sense or not. Sometimes you just need to try it and see if it works. Sometimes it will work, and sometimes it will not. So just go and see what happens. Now, at this point, I have everything basically between A and B. Everything is in parallel, and because of that, I can combine a lot of stuff. I don't want to interfere with my IO, so I'm not going to mess with this 2, but everything outside of the 2 is getting crushed, all right? So I is pushing, this is a milliamp, I is pushing upward into A, the 1 is pushing upward into A, and this 1 is pushing upward into A for a net current source providing 2 milliamps into A. I can do that, all right? As long as A gets 2 milliamps, it doesn't matter if it's getting it from one current source or 90 current sources. It gets 2, and that's fine. 6 and 6 are in parallel. When we have 2 of the same resistor in parallel, it just becomes half. So I have a 3 resistor there, and then the I that I cared for, and 2. Now I'm dealing with a current divider, okay? So I'll just call it I divider. Okay, so from the current divider, I can now just say, I should have written that in red, but whatever. I out equals the 2 milli, all right? And these are both Ks. I know they're Ks. So it's going to be times by the resistor that I don't want, which is 3K, divided by 2K plus 3K, all right? So the K's are going to cancel, and it's going to keep me with a milli. That's 6 over 5 milliamps. And that is my answer, okay? So some source transform, some resistor reduction, some current divider. All right, this is a great problem. It has a little bit of a lot happening here. Okay, so practice makes perfect. Just keep cranking it out. I hope this made sense. Follow the progression of events. All right, you always want to have your this. For me, this is neat. I think the red parts aside, the progression of arrows is a pretty neat progression. You want to have your circuits be solved in a neat way. Don't draw this over here, then draw this piece all the way down here, and then draw this piece out. Do not do that. You're going to lose track of what you're doing, and your professor is definitely not going to be able to follow your work. And that, if I were a professor and I were trying to follow messy work, I would not follow messy work. Okay, so make sure you keep things in an order. I like to just draw arrows to denote my order so that you can at least trace back your steps and see, maybe you made a mistake somewhere. All right. But all of that being said, I hope this helped.